Women Who Code Data Science community is a community formed in 2011 by handpicked technologists to change the industry experience for women engineers. Data science community has hosted around 233 events since 2019, and it has a strong presence of member base around 5,200 plus, and it has been spread around 20 plus countries. Please follow us on LinkedIn, Twitter, Instagram, and Facebook. You can also find us on our microblog platform, beacons.ai. Volunteers are welcome to join a community, get involved to make a difference by joining a network or a digital track of your interest. We have a dedicated section for communities on global partnership on hiring, and we also offer scholarships. Expand your technical proficiency and leadership skills, sharpening yourself. Here we have the speaker for today. Angelica Lo Duca is a researcher at the Institute of Informatics and Telematics of the National Research Council, Italy. She is also an external professor of data journalism at the University of Pisa. Her research interests include data science, data journalism, data engineering, and web applications. She used to work on network security, semantic web, linked data, and blockchain. She has published over 40 scientific papers at national and international conferences and journals. She is the author of the book Comet for Data Science, published by Packt Ltd, and of the upcoming books Learning and Operating Presto by O'Reilly Media and Data Storytelling with Python Altair and Generative AI by Manning. Here we have our speaker today. Over to you, Professor Angelica Lo Duca.
Hi, thanks for your introduction. Okay. Can I share my screen?
Yes, I stopped sharing.
Okay. Can you see my screen?
Yes, Professor.
Okay, thank you for the introduction. I'm really glad to be here with you today. And today we will talk about data storytelling with the DIKW Pyramid. Just some words about me, which you have already listened, but just to remind, I am a researcher at the Institute of Informatics and Telematics of the National Research Council in Italy. My research area are data science with a focus on data storytelling, web applications, data engineering. I'm also an external professor of data journalism at the University of Pisa and author of the 3 books, Data Storytelling with Python Altair and Generative AI, which is still ongoing, Comet for Data Science, which was published in 2022, and Learning and Operating Presto, which will be released by the end of this year. I am also a contributor at some popular blogs of data science, which are Towards Data Science, KD Nuggets, and datatalks.club. The topic of today is data storytelling. Data storytelling is building stories supported by data, allowing analysts and data scientists, and in general, everyone who wants to tell stories, to present and share their insights to engage the audience and inspire them to make decisions. You can see that data storytelling is not just telling a story with the data, but it has a very important objective, which is communicate an insight to engage the audience and to inspire the audience to make their decisions. These decisions should change something in our life, in other terms, should generate some value. But in this talk, we will focus on how to transform a data visualization chart into a data story. Data storytelling is a big field which can involve building presentations, for example, PowerPoint presentations or reports or other things. In this talk, we can't focus on all the things. We will focus only on how to transform a simple chart into a compelling story, data story. When I teach to my students how to transform a data visualization chart into a data story, I always say them to consider two main aspects. The first one is to consider the message to communicate. You can't leave your chart too generic. For example, consider this chart, which is the classical output of a simple data visualization, for example, done with the Matplotlib in Python or other data visualization libraries. But this chart, the problem with this chart is that it doesn't communicate anything. It's too generic, it doesn't have any focus, and the audience should interpret the chart. And the problem with this chart is that you have not elaborated or extracted any insight from it, and you are only representing raw data. In other words, there isn't any big or substantial difference between this chart and the raw table. The only thing that this chart adds respect to the raw table is that it shows the trend line, which it's in this case, it's an increasing trend line, but it doesn't communicate anything to the audience. So when you build your chart, consider the message to communicate. The second thing that I teach to my students is to consider the audience. The audience is the people who will read or will see your chart. And in particular, you have to calibrate your chart to the particular audience. Consider, for example, this chart. This is a simple pie chart, which shows two values, 70% and 30%. This type of chart is perfect if you want to explain a concept to a 5-year-old child. So, or to a general audience in general, because it's very simple. But if you have an audience composed of technical experts, this chart is too simple, because the technical experts want more details. So, when you build your chart and your story, consider also the audience. Well, the main point when you build your data story, the building block of your data story is composed of data. Data can be numbers, texts, images, audio, categories, or whatever you want. In the previous chart, we have represented raw data without doing any further step. Instead, if you want to turn your data into a story, you must perform some kind of data analysis. You have to analyze your data to explore them. And indeed, there are tons of books and videos on YouTube where you can learn how to transform your data and to analyze your data. And this is not the context where we perform data analysis. But I want to highlight a thing that recently I have read a book by Gary Klein entitled "Seeing What Others Don't, the Remarkable Ways We Can Gain Insight," where the author analyzes the problem of extracting of data analysis from a psychological point of view. And he states that there are 5 strategies that you can adopt to perform data analysis, which are connections, for example, build connections among things that you find in data, or coincidences, where you can, for example, look for repeatedly events, or curiosity in case you are inspired by a particular data, contradictions, or in the last case, a creative desperation. But in general, when you extract, you perform data analysis, at the end of your process, you extract an insight. An insight is a discovery of new patterns in your data. An insight is different from data because it's the result of your data analysis process, and it's not an intuition, because an intuition is something already present in the data, while an insight is a discovery of new patterns, of something new in your data. If you have found an insight, and this insight remains in your computer, you don't generate and create any value for the society. And so, once you have discovered your insight, you need to communicate it to someone. Communication has an effect the fact that it can generate a new idea which is a thought which enables you to create something new. Communication is different from information. It's not informing, it's not just informing, because as Brent Dykes says in his book, Effective Data Storytelling, when you inform someone, you tell him something. This is informing. This is a one-way direction. But when you want to communicate with someone, the link is bidirectional. You have to receive also the feedback from the audience. And this is communicating. Once you have your idea, you have to move to action, in the sense that you have to generate new value with your idea, which means offering something new to the public. The process, so to build a story from data, is starting from data and generate a new value. If you consider, if you go back to the first chart from data to value, you can see that you can ask whether this chart adds new value to your audience. The answer is no. This chart is not a data story. So the problem now is how we can transform data to produce new value. And then we are telling about data visualizations charts. You can use your experience, your expertise, but if you don't have this expertise, you can use another technique. In this talk, I propose you to use a model, which is the DIKW Pyramid. The idea is not mine, but it's extracted from the book Introduction to Data Visualization and Storytelling, a guide for the data scientist by Joseph Berengueres and Meribit Sandel. In this book, the authors use this pyramid, this model, to transform a simple data chart into a data story. How can we do this? We start from the bottom part of your chart, which is usually data are proposed usually as CSV tables, for example, or JSON files. But anyway, if you are familiar with Python, you have pandas data frames. Then you need to extract some meaning from your data, which is the insight which I described before, and you represent your data as a chart. And this is your representation. The chart should have a focus on something. It should highlight the most important parts, and it should bring to the background the less important aspects. And also consider, in this case, that you are representing, that your data represent people. And always consider people behind your data. When you build a chart, always consider the people behind your data. Next, you need to turn your data, your information into knowledge by adding a context. Context means adding a background. A background could be or some text which explains your chart, or maybe also an image, a photo. A photo is very useful because gives voice to the people behind your data. In this case, the background, for an example of background could be this. For example, if you are drawing a chart of your product sales over the last 10 months, a background could be a comparison with the previous period, for example, or you can also illustrate the campaigns that you have done to promote your product. This is the background. The final step, which is wisdom, does not depend only on the previous steps, but it also depends on the ethical framework to which you want to anchor your message. Because wisdom is the takeaway message, and the next steps you want to perform, to follow. You want your audience follows. And the next steps can be written or through another chart, maybe describing the alternatives of your the different proposals you have to deal with your problem, or can be a text which describes, for example, some next steps. Let's look, okay, the term the DIKW pyramid derives from the first letters of the concepts connected to this pyramid. Let's consider again the result of our chart. This is the main story we have built, As you can see, there are three main elements in our chart. The chart is composed of three parts: the background, the main event, which is this part, this central part, and the next steps. And this is the classical structure of a story. When you think about a story, you have a beginning with the setting of a scene, where characters do something. Then you have a main event, which is something which happens. And finally, you have a resolution, which is the next steps and the solution to the problem and the possible consequences and the next steps. We will see how to implement a practical case using Python Altair. Altair is the Vega Altair library. Altair for short is a declarative Python library for statistical visualization based on Vega-like visualization grammars. The Python Altair is a declarative library in the sense that it specifies what we want to see in a chart. We can specify the data and the type of visualization we want, and the library creates the visualization for us automatically. Declarative libraries are different from imperative libraries, which focus on building a visualization manually, for example, specifying the desired axis, size, legend, and labels. Examples of these imperative libraries are matplotlib or plotly. Personally, I prefer Altair because it's very simple to use, and it's intuitive to build charts. So Altair is in practice a Python interface to this Vega-like grammar, and Vega-like grammar is a set of rules which specify how to build a chart in JSON. It's a syntax in JSON which produces a chart. Vega-like is built at the top of the very famous D3.js JavaScript library for data visualization. And so also the produced chart are very are fantastic from my point of view. When you build a chart in Altair, you have to consider three main elements, which are the marks, which define the type of chart we want to build, such as a bar chart, a line chart, or other similar charts. Then we have to define the channels, which are the visual properties to represent, such as axis, colors, size. For example, the x-axis, the y-axis, the color we want to use, and so on. And finally, the encodings, which is a mapping of channels to data columns in the data frame. This is because Altair receives as input directly a pandas data frame. So you don't have to manipulate data to represent, to extract columns and so on. You can use directly a pandas data frame for your purposes. Let's look to install Altair. You can use your package manager and use pipe install Altair, and you have your code ready. Let's look at the first example. And for example, we can first we import pandas, then we import Altair as a library. Let's suppose that we have this simple data frame with a value column with 3 values, and a category category column with 3 categories. And we want to build a bar chart to represent this chart. this data. Simply, we write alt.chart, we pass the data frame as an element. We specify that we want to use a bar chart, so we use a mark bar, the mark, one of the parameters of the Altair. And then we specify the encoding, which defines the mapping between the channel and the column data frames. We specify the X column, for example, connected to the value column of the data frame. We use this syntax to specify that the value is a quantitative column. And also we can specify the Y column, the Y channel, sorry, that we link it to the category column of your data frame. The N here stays for nominal value. Then, if you are using Jupyter Notebook, you can simply write chart and press enter, and you will see your chart. Now, there is a case study, but before the case study, I don't know if there are questions and how it works now, if we want to answer to the questions before going to the case study.
Professor, we don't have any open questions right now.
Okay.
So meanwhile, I'll share the link to the notebook provided to us.
Okay. Perfect. So we can go to our scenario. Imagine that you work for a humanitarian organization that wants to apply for, sorry, just a moment. Yes, sorry. I will give the link to the scenario after, because now it's a theoretical description of the case study, and then we will implement. Imagine that you work for a humanitarian organization that wants to apply for funding from a foundation to help reduce the homeless people problem in Italy. And these humanitarian interventions can be applied to up to 4 Italian regions. This is the limits, the requirements to apply for funds. And the call for funds involves preparing a data visualization chart, motivating the selected regions and why to fund the proposal. Your boss asks you to do a study to figure out which regions to invest in and motivate your choice. You do a search on the web, and you find this data set, which is provided, which is an open source data set extracted from the ISTAT, which is an Italian Institute of Statistics. And you see in this data set that you have 2 important columns, the region, and the value, which represents the number of homeless people in Italy by region. You start by doing a first chart, and you present it to your boss. Here, your boss expected to see the 4 regions and how and why you should ask the funds for these regions. But instead, what you are proposing to your boss is a geographical map which only shows this information. Homelessness is more concentrated in the north-ovest, in Lazio and in some south regions. And the eastern side is less affected, with the exception of Puglia. You are only describing some generic concepts. So your chart, which is the simple chart you can build, you have some geographical data, and so you decide to use a map to show them. But instead, this chart doesn't answer to your question because it's too generic for your audience. The audience in this case is your boss. So you decide to change chart and to use a bar chart, which shows the number of homeless people in Italy by region. This chart is clearer than the previous one. You have 4 regions here, and you now know that the 4 regions are this one. But in this case, if you look at the 4 regions, at the first 4 regions, you can see that these are the most populated regions in Italy. This is because your chart, in your chart, you have not normalized data. You have shown absolute values, and obviously, the bigger the region, the bigger the number of homeless people. And so this chart is not realistic because you have to normalize data by the population. When you have geographical data, always keep in mind to normalize your data. And so you decide to normalize your data, number of homeless people in a population of 1,000 in 2021. And now you have 4 different regions, the top 4 different regions. You have transformed your chart, and you have also shown the top, you have highlighted the 4 regions. At this point, you have built the main point of your story. The main point of your story is this one. Now you need to add a background, which is a brief description of the homelessness problem in your community. You have the main point. There are 4 regions where the problem is urgent to solve. And finally, you need to add the next steps, a list of objectives that will help you achieve your goal. The first thing to add the background, we can, for example, use the title. Here I have added a background, which is also half a background and half a next step. And the background is: together, let's make a difference, support our project to help the homeless. And here there is the part related to the description of the problem. Homelessness is a heartbreaking reality that leaves individuals and families without a stable home, leading to devastating consequences such as poor health and social isolation. You can also add another type of background to your story, which is, for example, some images, some photos. I have generated these photos with Dolly, which is a generative AI tool which builds images based on our description. And here, adding these photos to the chart can help the audience to understand the presence of people behind your data. You are talking about homeless people, and so put them in your chart. Give them a voice in your chart. The final step instead is adding a call to action. What do we propose to reduce this problem? For example, we can describe how we will use the funds that we will have from the foundation. For example, we will use the 35% for shelter and housing, the 25% for job training, then education, healthcare, and basic necessities. This is the final chart, which is very different from the previous and preliminary map that we have built. Now we have a story from in our with our chart. You can learn other stories and other techniques to build data storytelling to turn your data visualization charts into data story in my book. And today I have a special discount code for you if you want to buy the book or learn something new. Here, this is also the link to the book. Now we can proceed with the last part of this talk with the practical implementation of the scenario we have seen. You can download the code from the GitHub repository of the book. We can go to the GitHub repository of this book, We move to chapter 5. And here we have our case study, which is this one. Or if you prefer, you can use the Jupyter notebook, or you have also the simple Python version of your code. I will show you the GitHub, the case of the Jupyter notebook. Just a moment. Here there is. We can open this case study. We start by importing the pandas data frame, the pandas library, and the configuration file which renders our chart. We can look at this file, which is included in the repository. And this file simply sets some parameters such as the height, the width of the chart, the label font size, the title font size, the font size of the text, other useful information, the offset, the list of colors, and finally the configure layout, which we will see at the end. I have defined this function to make easy to avoid to repeat the layout every time. Firstly, we start by reading our file. Here, with respect to the example that I showed you previously in this slide, the name of the region is territory, but otherwise the file is the same. We select only some fields, in particular, respect to the citizenship. We have homeless people related to Italy or foreign. This is a foreign people, and which is the citizenship, Italian or foreign, or the total. In our case, we select the total citizenship. Then we have to perform some data cleaning to adapt to a map. And so we do some data cleaning processing by changing Trentino Alto Adige to Trentino Alto Adige Sud Tirol to make the map have the same name as our dataset. Okay. And then we calculate we filter only total age, total sex, and total citizenship, because we have data from male, female and total, and age, it's divided by different type of ages, different categories. We could investigate also this aspect, but we don't have time. And so we do this filter. Then we want to draw a preliminary map in Altair. To do it, we need a topo.json file which contains the geographical boundaries of your map. In my case, I have taken this one, which I will show you. This is the raw topo.json file. You can see here the file which contains the boundaries of your region. If you are familiar with drawing map, you know this. In Altair, to do it, to draw a map, you need to use the mark geoshape mark. If you remind, we have used the mark bar to draw a bar, but in this case, you can use mark geoshape. And here you pass the source as a parameter of your chart, and you need to encode, you can encode different channels, which are the tooltip and the color. Here you have a JSON as input file, and so as tooltip you have to pass an element of your file. In our case is properties.regname. And also the color is given by the value. Value is an element within the GeoJSON. Sorry. No, sorry, wrong. Just value, sorry, is this value here. Because you are combining your chart, your map with the other map, the other data set, which is this through this combination. Because you can combine more data sets in Altair using this transform lookup function. And you have to, this function in practice performs a join, and you have to specify the parameters for joining. This is the parameter in the original map, and this is the parameter in your map. Okay, and here we we run the code and we build the map. We have said that this map is not useful, doesn't represent a story, but just for completeness, I have shown you how to do it. Then we can change type of chart and use a mark bar to draw our chart. We use the color. Color is stored in that configuration file. And here we specify the channel. A Y channel defines our Y-axis, which is connected to the territory column of our dataset. We decide to sort our values based on the descending order specified by the value of the X channel. Then we also specify the axis parameters, such as the title. In this case, we remove the title. Then we also specify the X channel by defining the value column and some properties of the channel, such as the title. We also set the general title of this chart by specifying the properties. We use the configure layout function here to specify the label font size and title font size of the title, the legend, and the view, other layout options. and we run this. As you see, we have used the value column has the X channel and the region as the Y channel. And we have decreased it, we have sorted the labels based on a decreasing order of the value. Now we need to normalize data, because data are not normalized, as I said before. Here we can save the chart as an HTML file. And here we have to normalize data. We can combine, we can read the population dataset from CSV here. And as you can see, we have an index here, an ID, which is the same of our dataset, if you remember here. And so we can join data. You can have here the territory, the sex, the age, and the value of the population. Also here we have to select the total population and the total for sex. Okay. Here we compare the length of our dataset and the previous one to see if they are the same. And then we can, here we can control data, and then we can join the two datasets, simply using the join operation. We set the index in both datasets with this to this one, which is the same, and then we join the two datasets. We can see the output here. You can see here you have the value for the population and the value for the homeless. Now it's simple. We can calculate the ratio for 1,000 inhabitants. And now we can draw again the same chart as the previous one, and we can, but now it contains normalized data. Instead of value, we represent the x-axis here. The next step is adding context, which means this is the previous chart, and here we add the title. In Altair, we can specify the title simply using title and a string, or specifying the title params, which enable you to specify the text, the subtitle, the text, and the subtitle. You can use a list, as you see here, to specify the title, and the list, each element of the list is a line in the title. You can also specify the subtitle as a list of different lines of your subtitle. You can run this one, and you have the title in 2 lines and the subtitles in 2 lines. The final step includes adding an image, and here I can show you are using mark image to draw an image. So you can see how it's simple in Altair to use to draw something. You only need to specify the URL to the image and the position of your image. We are adding 2 images, if you remember, and we can also concatenate multiple charts. This operation combines two charts, overlaps two charts, while this OR operation instead appends a chart after another. So you can have, if you look at this chart, these two charts are in the same place, but they are in different positions, and the other is appended, the chart is appended to the previous one. Finally, you can add the next steps. In our case, we have another data set, which shows the percentage of different categories that we want to represent. And here we can build a different donut chart for each value. So for each chart, we build this donut chart using the marker, where we have to specify the dimensions of the donut, of the whole of our donut. So the inner, the outer radius, and the outer radius. For arcs, we don't specify the X and Y channels, but the theta and the color channel. And here you have defined the donut, and also you can put the percentage inside your donut, and you add here a text. And you set the properties, and you concatenate the different chart you have. Finally, you can configure the final layout. This is all. Just last thing. Thanks. I'd like to thank you for the attention. If you want, you can read more articles in my blog, or asking me your contact in LinkedIn. I will be happy to connect with you. Thank you for your attention.
So we don't have any questions in the question and Q&A tab. Meanwhile, I'm a little curious to understand about the topo.json file that you have shared. Like, I believe it is an extension of GeoJSON. And how do we do the preliminary pre-processing for a topo.json file, especially? Do we need to consider any special geometrics or coordinates, or how do we do that?
Yes, when you want to just a moment. When you want to add a GeoJSON to your map, just a moment, you have to find here. Okay, you have to find where is the definition of your object. Here, maybe it's too small. Okay. Here, your JSON here defines a geometry collection, which contains all your shapes. And so, for example, to search which kind of property you have to add in your file, you have to select here where is your geometry collection. For example, in Altair, you have selected the property here, and then the name, reg name here. So you have to look at the geometry collection then the geometries, and within the geometries, you have to search for properties where you have information related to your polygon, your data.
Okay. So any specialities about using Altair software? Like, do we have anything that leverages with the geodata that we have in hand with the Altair software?
Can you repeat, please? I didn't get the point.
Okay. Do we have any special feature that Altair software provides for the geometrics data?
Only this mark geoshape function, which permits you to build geographical maps, but no other features it does provide. It uses this topo.json file format to read files. But particular things, no, it doesn't contain.
I was just wondering, there are many predictive analytics software which is available, and there are many automated enterprise software which is there in the market. What is the reason behind like choosing Altair for our data storytelling part, and how does it really influences this DIKW pyramid?
Yes, you can use any tool that you want, indeed. But the main problem is, it is also the idea behind the book, is that in many cases you do analytics in Python. All the steps of your data science life cycle in Python, and then you migrate to another software, to an external software for data storytelling. And this you need to export your data and to load into another tool. Instead, if you have all the things in Python, you have a simple and unique framework where you can perform all your data science life cycle. And if you change something at the beginning of your data science life cycle, for example, in the data cleaning phase, you have all the pipeline in Python, and you don't need to export things. You have everything ready in Python. I'm aware that maybe tools like Tableau or Power BI are more powerful to represent, to build reports or to represent data visually. But I think that for a programmer, for a developer, using a tool such as Python could be more familiar. And instead of proposing also in a Jupyter notebook a raw chart, it's better to have something not very raw, but a data story also in a Jupyter notebook. This is my position, and I think that you can understand it because, yes.
Okay. So, we are, by the end of the session, I think we are good at having an informative session on exploring the data storytelling part with one of the most widely used enterprise software, Altair, and also with a few other options which you have enriched us with this session. And we look forward for your book, and we encourage you to provide much more information to our community and make us enrich with the data storytelling part, and with all the information that you have. And I think we are excited to know more about your book and the next release.
Okay, thank you very much for hosting me today. Thank you.
You're welcome. So As already mentioned, the YouTube channel will have the link to the recording of the session and will be posted shortly. And thanks for everyone who has joined for today's session, and we wish you all a happy weekend. Let's gather together for one more session with the Women Who Code Data Science community. Thank you. Bye-bye.
Bye-bye.